Hello friends, how are you? Hope you people are doing well, and today we came up with some question on data structure. So we will do some question on that and we will see our concept, and let's start. First question is, which one of the following is not the type of queue? Options are linear queue, circular queue, double-ended queue, single-ended queue. So guys, it is important, it is saying not type. Okay, so option is answer is D. Single-ended queue. Queue has two ends. So if it is a queue, it has two ends. One end is used for the insertion and another is for deletion. So we are inserting, one is for deletion. Therefore, it is not possible for the queue to have a single-ended queue. So it must be doubly-ended. Okay. And all other are options or type of queue. Okay, so we will see what is queue. Queue can be defined as a order list which enable insert operation to be performed at one end is called rear, and delete operation to be performed at another end called front. So like this we saw in image, it is front and it is rear. Queue is referred to be first in first out. So guys, sometimes they ask also queue is first in first out, like that. Okay, example is people are waiting in a line for a rail ticket. It's from a queue. Okay, so generally we say, if we see there is a mob outside some where, we say please be in queue. So like that. Okay, so that comes from this only. So here deletion operation is called dq and insertion operation is called inq, and this is the front end and this is the rear end. From rear end we are inserting and from front end we are deleting. Okay, application of queue. So what are the applications? These are the given applications, so just read it out, so it will be helpful if someone asks question on that. Okay, so generally as a waiting list, single shared resource like a printer or disk, hard disk or CPU. Asynchronous transfer of data, where data is being transferred at the same rate between two processes. Example, a pipes, file, IO and sockets. They are act as a buffer also, like MP3 media player, CD player. Okay, so it is a add remove song, it's like a playlist. And operating system for handling interrupts. So these are the applications, so that can be asked in exam. So basically queue is we are making a list out of that, so it's first first in first out will be there. So that is the concept of queue, and it is very simple. So if you understand like that, so you can make a question answer of questions. And sometimes they ask also time complexity or space complexity. Okay, so these are the things, so you will need to write, you need to learn this table, so you will get. So we will see some like insertion here and insertion in worst case and average case. So insertion have complexity of 1. Same is for deletion. For access also we have n number, and for search also. Okay, so these kind of thing is happening. So you just learn this table and it will be helpful for your questions in exam. Next question, the time complexity of in-queue operation is 1 n log n and log n. So answer is 1. 1. The insertion is performed at the rear end, which is directly accessible. Therefore, it takes one single time to insert element in a queue. So like this, it is called insertion. Okay, so that we saw in our that we are inserting. So it will directly access. So it is not taking a time. So it's single access. So that's why time complexity is 1. Okay, hope you got it. Next question, which of the following that determines the need for the circular queue? Options are avoid wastage of memory, access the queue using priority, follows the FIFO principle, and none of the above. So guys, if what it is asking, need of circular queue, that is important. Okay, so correct option is A, avoid of wastage of memory. In a linear queue, there are chances of wastage of memory because if the rear is pointing to the last element, where the front is pointing to the element other than the first element, it means the space allocated before the front are free, but it cannot be reused as a rear. Rear cannot be incremented. In contrast, the last element is connected to the first element in a circular queue. If the initial space are vacant, then the rear can be incremented by using the statement rear plus 1. Okay, so what it concludes? It concludes that circular queue avoid wastage of memory. Okay, so it is a linear portion, and like this we implement circular queue. Okay, so here we are accessing, here from we are deleting. Okay, we will make a separate video on that for difference of linear and circular, so we will explain there. And for this question we already saw it is avoid of wastage of memory. Okay, next question, in the linked list implementation of a queue, where will the new element will be inserted? Options are at the middle position of the linked list, at the head position of the linked list, at the tail position of the linked list, none of the above. So answer is C. If the queue is implemented using linked list, then the new element will be inserted at tail position of the linked list as a queue, as queue follows FIFO principle, in which the new element will be always added at the end of the queue. Okay, so linked list, so always it is added in the last. Okay guys, so if queue is implemented with any of the things, stack or linked list or anything, the basic of the queue will remain same. So if we know the basic of queue, how queue is working, answers will be done. Okay guys, next is how many queues are required to implement a stack. Okay, options are 3, 2, 1 and 4, and correct answer option is B, because one queue is required to perform the push operation while the other queue is used to perform the pop operation. So stack is like that. Okay, so if we are inserting element, it is called push, and if we are removing element, it is called pop. Okay, so we will require two queues, one for push operation and one for pop operation. Okay guys, next is, which one of the following is not the application of queue data structure? So guys, what it is asking about the application, and it is saying not the application. Okay, so options are resource shared between various systems, data is transferred asynchronously, load balancing, and balancing of symbols. So D is not the application. Okay, so A, B, C are the application of that. Option A, if we say about resource shared between various systems, is the application of queue data structure, as it allows to align all the requests for the resources in a queue. Okay, like we saw in case of, we discussed in printer. Okay, if everyone is giving command, so it will make a queue of that. So first come first serve will happen, means first in first out will happen. Whoever give the request first, that request will be processed first. Okay, next is option B, data is transferred asynchronously is an application of the queue data structure. Here asynchronously means that data received at a different rates as a sent. So that also we discussed when we discussed queue here in is some time back. So that is also application of that. And option C, load balancing, is also an application of queue data structure, because all the requests from the client are stored in a queue and it distributes the request to the client one by one. That is called load balancing. Okay, so option D is correct. Option D is correct for this question. And balancing of a symbol, balancing of symbols is an application of stack. Okay, it is an application of stack. Okay, application of stack data structure. Got it? Okay, next question. Which of the following option is true if implementation of a queue is from linked list? Okay, options are A, in queue operation new nodes are inserted from the beginning, and the in DQ operation nodes are removed from the end. Option B, in queue operation new nodes are inserted from the end, and in DQ operation nodes are deleted from the beginning. Option C, in queue operation new nodes are inserted from the end, and DQ operation nodes are deleted from the end. And both A and B. So correct option is D, both A and B. As we know that queue has two ends, that is one for the insertion and other for the deletion. If queue is implemented using linked list, then it can be done in either of the ways. So both A and B are correct. Okay, next question. The necessary condition to be checked before deletion from queue. Options are overflow, underflow, rear value, front value. Correct answer is B, underflow. Before deletion an element from the queue, we first need to check whether the queue is empty or not. So we need to check the condition of empty for deletion. Okay. Next question. Which data structure is the best for implementing a priority queue? Option stack, linked list, array, heap. So it is asking best. Okay. So answer is D. All the data structures mentioned here that are given in the all or here in the options can be used to implement a priority queue. Means from all we can implement, okay, priority queue. But the most efficient way for the implementing a priority queue is heap data structure, because it is asking best implementation, but we can implement from all these. Okay, so we will see what is priority queue. It is an abstract data type, behaves similarly to the normal queue, except at each element has a priority, because we are giving priority on some conditions, so it is called priority queue. Element with the highest priority would come first in priority queue. The priority of the element in a priority queue will be determined in order in which the elements are removed from the priority queue. Okay, so which is having highest priority will go first. Priority queue supports only comparable elements, which means that elements are either arranged in ascending order or descending order. Okay, so these are the important thing on that, or either in ascending order or descending order. Example, some values we have inserted in a priority queue with an ordering imposed on the values is from least to greatest. Therefore, one number would have the highest priority while have the lowest priority. So it's like that. So if it is least to greatest, it is like that. One is first and is last. So it will have highest priority and it will go first out. So these kind of thing happening in priority queue, because it have a priority, that's why it is called priority queue. And what are the characteristic of that, that is also important. So every element in a priority queue has some priority associated with it. An element with higher priority will be deleted before the deletion of lesser priority. If two elements in a priority queue have the same priority, they will be arranged using FIFO principle. That is very important, and it has already asked in so many exams, and it is important. If someone asks from priority queue, this question might come. Okay, let's see next question. Which of the following principle is used if two elements in the priority queue have a same priority? So guys, options are LIFO, FIFO, linear tree, and none of the above. So answer is FIFO, we have seen, because it is saying about the same priority. Okay, next question. Which of the following statement is true regarding the priority queue? Options are process with different priority can be easily handled, easy to implement, deletion is easier, and none above of the above. So what he is asking, not true. Okay guys, it is important, not true. So correct option is C. In worst case, the deletion is not easier, as we have to we have to traverse to the n element until the element to be removed is to be found. Okay, so that's why deletion is not easier in case of priority queue. Okay, others are okay for that. So guys, that's all for today. Hope you have understood something and you have got some knowledge on the data structure, and hope you can answer at least 80 to 90% question asked on the basics of the data structure. So thank you for that. Thank you very much.